welcome to True Projects. In this video, we are going to explain about the project title, which is Sentiment Analysis of Reviews in Natural Language Roman Urdu as a case study. This project revolves around the sentiment analysis of reviews in natural language Roman Urdu. It addresses the problem of comprehending and classifying feelings expressed in Roman Urdu literature. In an increasingly digital world where opinions are freely exchanged via social media platforms, the demand for automated sentiment analysis tools has never been greater. This project endeavors to provide a solution to this growing demand by harnessing the capabilities of machine learning and natural language processing. The project desire is to get significant insights by automating sentiment analysis of Roman Urdu text, allowing for faster and more informed decision making in a variety of fields like business, social media, customer feedback analysis. The goal of the project is to use a variety of machine learning methods to perform sentiment analysis on Roman Urdu reviews. To effectively detect text attitudes, these techniques, which are logistic regression, random forest, ADA boost, SGD, K-neighbors, decision tree, multinomial name base, support vector machine, gradient boosting, MLP, CAT boost, and a voting classifier are used. This diversified set of algorithms provides strong sentiment analysis for a wide range of text difficulties and circumstances. We want to extract relevant sentiment insights from user-generated material by using these techniques. This project addresses the need for automated sentiment analysis in a variety of applications, allowing for faster and more precise decision making based on public sentiment on various topics. Coming to requirements, we need hardware requirements in that operating system of Windows, processor of i5 and above, RAM of 8 GB and above, hard disk of 25 GB and above, and software requirements are Anaconda 3 and Visual Studio Community version. In the flow of work, we have designed few modules to implement the project. The first module is importing the packages. In this module, the project begins by importing necessary Python libraries and modules, which are NumPy, Pandas, Scikit-learn, TensorFlow, and Seaborn and Matplotlib. These steps involve in loading the tools required for data manipulation, visualization, and machine learning. Coming to the second one, exploring the dataset. This module involves the initial exploration of the dataset. This step involves loading and examining the dataset to understand its structure, checking for missing values, and gain insights into its features and distribution. The third one is data processing. Within this module, data pre-processing is conducted. This step involves tasks such as handling missing data, encoding categorical variables, and scaling numerical features to prepare the data for machine learning models. Fourth one is visualization using Seaborn and Matplotlib. In this module, data visualization libraries like Seaborn and Matplotlib are utilized. This step involves creating plots and graphs to visually represent the data's patterns, relationships, and distributions. Next one is feature selection using formal data. This module focuses on feature selection. Here, the step involves choosing the most relevant features or variables that contribute significantly to the model's predictive power while discarding irrelevant or redundant ones. Next one is count vectorizer. In this module, count vectorization is applied. This step involves converting text data into a numerical format, specifically word frequency counts, which is essential for text-based machine learning tasks like sentiment analysis. Seventh one is splitting the data into train and test. Within this module, the data set is divided into training set and testing set. This step involves partitioning the data to allocate a portion for training machine learning models and another for evaluating the performance. Coming to the building the model. In this module, various machine learning algorithms are implemented. First one is logistic regression. It is a binary classification algorithm that models the probability of a binary outcome based on one or more predictor variables. It is used for its simplicity and interpretability. It is suitable for binary sentiment classification, where the goal is to predict positive or negative. Next one is random forest classifier. It is an ensemble learning method that constructs multiple decision trees during training and combining their predictions to improve accuracy and reduce overfitting. It is used for its robustness and ability to handle non-linear relationships in the data. It is effective for sentiment analysis when dealing with complex text data. Next one is ADA boost classifier. It is an ensemble learning technique that combines multiple weak learners to create a strong classifier. It gives more weight to misclassified data points in each iteration. It is used to improve classification accuracy by focusing on difficult to classify examples. It can enhance sentiment analysis performance by giving more attention to challenging sentiments. The next one is SGD classifier. It is stochastic gradient descent. SGD is an optimizing algorithm that is used for training various machine learning models, including linear classifiers like support vector machine and logistic regression. It is employed for its efficiency in handling large data sets. It can be useful when working with a substantial volume of text data for sentiment analysis. Next one is K-neighbor classifier. K-nearest neighbor classifier is a simple instance-based learning algorithm that classifies data points based on the majority class among their K-nearest neighbor. It is used for its simplicity and versatility. It can be effective for sentiment analysis tasks where the similarity between text samples is essential. Next one is decision tree classifier. Decision trees are tree-like models that makes predictions by recursively splitting data into subsets based on most significant attribute at each node. It is used for its interpretability. They can help uncover the most critical features in text data for sentiment analysis. Next one is multinomial naive Bayes. It is a probabilistic algorithm based on Bayes' theorem. It is commonly used for text classification tasks. Multinomial naive Bayes is well suited for text-based sentiment analysis due to its efficiency and effectiveness in handling text data with multiple classes. Coming to support vector machine, SVM is a powerful supervised learning algorithm that is aimed to find the hyperplane that best separates data points into different classes while maximizing the margin. It is used for its ability to handle high-dimensional data, making it suitable for text classification tasks like sentiment analysis. Next algorithm is gradient boosting. It is an ensemble technique that builds an additive model by combining predictions of multiple weak models, typically decision trees. It is employed for its ability to improve model performance by focusing on errors from the previous models. It can enhance the accuracy of sentiment analysis. The next one is MLP, which is multi-layer perceptron. MLP is a type of artificial neural network with multiple layers of nodes, which are neurons that can learn complex patterns and relationships in data. It is used for deep learning based sentiment analysis. It can capture intricate patterns in the text data, but it will require more data and computation. Coming to CAT-boost, which is categorical boosting. CAT-boost is a gradient boosting algorithm designed for handling categorical features efficiently. It is known for its robustness and high performance. CAT-boost is used when dealing with the datasets that include categorical features, and it can enhance the accuracy of sentiment analysis models. Coming to the voting classifier, which include logistic regression, random forest and SVC. Voting classifier combines predictions of multiple individual classifiers to make final predictions, typically by majority voting. Voting classifier combines the strength of various classifiers, offering a balanced approach to sentiment analysis, improving overall accuracy. Next algorithm is RNN, which is recurrent neural network. It is a type of neural network designed for processing sequences of a data by maintaining a hidden state that captures context from previous time steps. RNNs are used for sequence-based sentiment analysis as they can capture contextual information in text data, making them suitable for tasks like analyzing reviews. Coming to the CNN, which is convolutional neural network, it is a type of neural network commonly used for image analysis but can also be applied to text data through techniques like word embeddings. CNNs can capture local patterns and features in text data, making them effective for sentiment analysis tasks, especially when combined with word embeddings. Coming to the next module, which is training the model. Within this module, machine learning models are trained using the training dataset. This step involves teaching the models to make predictions based on the provided features. Next module is Flask framework with SQLite for sign up and sign in. In this module, Flask, a web framework, is used to create a web application for user authentication interaction. SQLite is employed for user sign up and sign in functionality. This step involves setting up the web application and database. Next one is user gives input, which is Urdu input. In this module, user interact with the web application, providing the Urdu input, typically in form of text for sentiment analysis. Next one is the given input is translated and pre-processed for prediction. If required, user input may be translated or pre-processed for compatibility with the model's input requirements. This step involves preparing the user input for sentiment analysis. The next module is train model is used for prediction. In this module, the pre-processed input is fed into the trained machine learning models. This step involves making predictions regarding sentiments using the machine learning models. The last module is final outcome is displayed through frontend. In this module, the predictions from the models are presented to the user through the web application's frontend. Users can view the sentiment analysis results, gaining insight into the sentiment expressed in the provided text. Comparison graph. Here, on the x-axis, we can see all the algorithm names represented, and on the y-axis, we can see the accuracy scores. This is the comparison graph of this particular project. Among all the algorithms, MLP is performing well, so MLP is used for the prediction purpose in the front end. For execution, we need to open the code folder. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. This is the app.py file. This file contains the information related to the front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file, which contains the algorithm information, which will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for data science. It is a sign-up file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the File Explorer. I will copy this. Now I will open the Anaconda prompt. Here, using the cd command followed by the space and then paste the copied path. This command is used to change the current directory to code folder's path. Now I will click on the button Enter. So this has changed to the code folder's path, which is current directory now. Now we need to type python space app.py. This will compile the app.py file using the command python space app.py in the Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on Enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is this one, and the port number, which is this one, unless configured differently. Now we need to copy this local link provided by the framework and paste it in any browser. I will copy it and paste it in the Google Chrome. Here I will paste it and click on Enter. So this has redirected to the home page, which is displayed in the browser, and this is developed by using the front-end Flask framework. Now we will click on the button Login. Here, first I will click on the button Sign Up. We need to give all these details if we are registering newly. I have already registered, so I will directly sign in. Here I need to give the credentials of mine and the password. I will click on Login. So this has redirected to the home page where I need to enter the message here, then click on Predict. After that, the message will be predicted and translated into English. So first here I will enter the message. So I entered the message here. Now I will click Predict. So the message is converted into English, which means it is translated into English. Then it has predicted the label of that particular message, which is the category type is positive. Now we will try with the other message. I entered the other message in the Urdu. Now I will click on Predict and see what will it predict. Here it is translated in English and It has predicted that the category type is positive. Now we will try with the other message. So I entered the other message and I'll click on predict. Here the message is translated in English and it has predicted that the text type is negative. In this way, we can upload any text and type any text. For that particular text, it will translate into English and then predict the sentiment which is positive or negative. Now we will log out of this page. Using the capabilities of machine learning and natural language processing, the project efficiently handled the difficulty of sentiment analysis in Roman Urdu reviews. Project accomplished successful sentiment categorization using a broad set of algorithms, delivering important insights into user sentiments. The project's relevance stems from its capacity to automate sentiment analysis and hence streamlining decision-making process in numerous sectors such as business, social media, and consumer feedback analysis. This project helps individuals and organizations to make informed decisions based on a public sentiment by simplifying the extraction of sentiment information from massive quantities of text data, thereby improving their comprehension of user opinions and comments.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.